Hey, hi everybody. Well, we had another great week of school this past week. Great weather. We were able to get outside a little bit, which is awesome. Um, but I'm guessing by the time you're watching this, we may even have snow on the ground. We'll see. It's Wisconsin. Who knows? But we had a great week, as I said. This past week, our focus transitioned from, if you remember last week, we were focusing on adding integers using a number line. Well, this week, our focus shifted a little bit to a new model called counters. So counters, if we were in a normal state of affairs in class, we would have little chips, and each student would get these little chips that were consisted of two different colors, red and yellow. Red representing negative and yellow representing positive. So instead of that, we modeled with just a normal positive sign and a negative sign. And so these little counters that we talk about are just simply, again, positives and negatives. And if you remember, an integer was defined as a whole number, like 3, and its opposite, so negative 3. So you can kind of understand why we're using these counters, positive and negatives, to model this week, adding, and we also ended the week with subtracting, where things got just a little bit more difficult. So we're going to start off this week, as I said, modeling addition. So we started off, just show a couple examples of a problem. So for example, if I had something like this, we have negative 3 plus 4. So in our model, we're going to start off with 3 negatives, 1, 2, 3. And we're going to add to that 4 positives, 1, 2, 3, 4. So first of all, we have to ask ourselves, what happens when a negative and a positive collide? Okay, well, in the real world, if I have $1, that could be represented by a positive $1, right? But if I spend that dollar, that would be an example of a negative $1. Well, my balance, if I have that dollar and I spend that $1, my balance is 0. So this was our first property we talked about this week, something called the additive inverse property, which simply means when we add opposites, we always get 0. So essentially, they cancel each other out. And this is a very, very big property and a very important rule that students need to understand. So we spent some time just looking at this property, so that now, when we come to our first problem that we're modeling here, we can see, hey, I have a couple of negatives and positives in this case. And so to model this, what we did is we just circled, another word for it are 0 pairs. So pairs of positive and negatives that equal 0. So we circle them so that we can show them, and we simply just cross them off. Because again, they cancel each other out, like I just showed with my 0 balance, leaving me with just 1 positive. Now the great thing about this model is, as I told students, when we're looking at solving these problems, and we're meeting in our groups, correcting these problems, we can actually prove our answer is correct. Okay, no longer do we have to just sit and argue and try to figure out who is correct when we're correcting with our group. We can literally prove it. So negative 3 plus 4, we got a positive 1. Okay, so let's try another one. So let's go to what happens when we add 2 negatives. Well, here are my 2 negatives, and here's my 3 negatives. So I got negative 2 plus another negative 3. Well, notice I do not have any opposites. I do not have any 0 pairs. So nothing is going to be canceled out here. So my answer is going to be exactly what I see here. I have a total of 5 negatives. So all the while we're doing this, we're also looking at patterns. What is happening? So for example, we're noticing a pattern here. When we added our 2 negatives, we got 5 negatives. Our answer was negative. Okay? What happens when we change those 2 negatives to positives? Well, obviously, students, this takes them all the way back to elementary school when they first learn how to add. Okay, we know the answer is not negative 5, but a positive 5. Well, again, we can model this. Here's my 2 positives, along with, here are 3 positives. Again, there are no 0 pairs, nothing's canceling out, so it's like, hey, I have $2, I'm gaining 3 more dollars. I have a total of $5. So what happened was, we looked at patterns. When we added 2 negatives, we always got a negative. When we added 2 positives, we always got a positive. So essentially, when the signs are the same, we end up with a sum that is the same sign. The sign doesn't change. But what about when we added a positive and negative? That was my first example, remember. Well, now it depended, right? And what we said was it depended on which one had the higher absolute value. And you might remember in my last video last week, I talked about that rule. So for example, if I have 3 plus a negative 4, the absolute value of 3 is 3. The absolute value of negative 4 is 4. 4 is bigger than 3. So that means, since my 4 was negative, my answer is going to be negative. Okay? And again, the great thing about the counters model is that we can literally count them. We can see that there are more negatives than there are positives. Okay? So this is how we started the week. And students did pretty well. We had a quiz on Wednesday on just adding integers. Adding integers, again, seems to be, students seem to comprehend that a lot quicker. But then we ended the week with subtracting integers, okay? And again, if we build our solid foundation with integers and we start off with adding, we really are understanding what's going on. And I saw that typically what happens is subtracting integers is just that much easier. So we start off with actually just a very, very basic problem like 3 minus 2. So how do we model this? Well, we first had to talk about what does this symbol mean, right? So way back in kindergarten and first grade, I asked the students, what did your kindergarten and first grade teacher call this? And they remember their teacher saying, well, that meant take away or minus. And then we got to about first, second grade, and we started calling it subtraction. And then we got to about 5th grade, and all of a sudden, this symbol appeared before a number. And all of a sudden, we called it a negative sign. And I informed them of the new one that we can also call this. We can also call this the opposite. Okay, so this sign means opposite. So this would be the opposite of 2, which is negative 2. So all of those words that we just connected with this symbol, they are all the same thing. So for example, I could say 3 minus 2. I could say 3 minus 2, or excuse me, 3 take away 2. I could say 3 negative 2. Now, we said that doesn't really make a whole lot of sense, right? If I say 3 negative 2, but actually, that is a negative 2, which we're going to get to. So, in my first problem, 3 minus 2, I'm starting off with 3 positives. Okay, so our goal here is we said, well, we have to maintain that value of 3 positives. I can't change that value, okay? It's telling me then to take away 2 positives. Now, this is where it's a little tricky, because notice a moment ago I said, well, that's really a negative 2. But notice if I cover that negative sign up, because I just said that was a takeaway. I'm taking away. So if I say take away, well, that means I've already used that symbol. I can't use it twice. So some students will get confused and they'll say, well, I'm going to say this is 3 take away. That's a negative 2. Well, if I say 3 take away a negative 2, I have now rewritten the problem. It looks completely different, and we'll get to one that looks like that in a second. But this is not 3 take away negative 2. This is simply 3 take away 2. So I'm going to call this 2, for the purposes of this model, a positive 2. I'm going to take away 2 positives. And this is how we model taking away. Okay, and notice again, this is different than adding. When I was adding, I didn't take anything away. Now I am subtracting, and so I need to take away something. And in this case, I'm taking away those 2. And again, the great thing about this model is I can literally see the one that's remaining. Okay, so again, that was a pretty basic, pretty easy problem. And then let's try another one. So what happens if I'll just make that 3 a negative this time? So now I'm going to start off with 3 negatives. So here are my 3 negatives. And again, I have to maintain this value inside this circle. I can't just change and put a bunch of things in there, which is going to change the problem. So here I have 3 negatives, and it tells me again to take away 2 positives. Well, I don't have 2 positives to take away. So we related to in the real life, well, okay, if I needed some money to do a project in my house, and we just got done doing a project on this, where we researched and looked at taking out a loan and how that works. So in this case, we kind of use that analogy. I'm going to take out a loan. I'm going to borrow the 2 positives that I need. But notice if I do that, the value inside my circle has changed. I changed the problem. So I have to do something about it. So I reminded the students, if I borrow $2 or 2 of anything from the bank, I'm going to have to pay it back. So I want my balance in the end of that transaction to be 0. So how do I get 0? Well, this goes back to that 0 pair idea. I'm going to bring in or pay back with 2 negatives. Because now if you notice, this part right here, that's 0. That's nothing. So the value inside my circle is still 3. So now, again, why did I do that? Well, it said I needed to take away 2 positives. I now have 2 positives that I can take away. And you can see again, I can literally see the result. I can count them, 1, 2, 3, 4, 5. I'm left with 5 negatives. So my result was 5 negatives. All right, let's try one more. Okay, so let's try something a little bit different. Let's go to, what if I had 4 minus, now this is where it got a little tricky, -2. Okay? So again, we're looking for patterns, and all of these problems that we're doing, we're looking for patterns. And we ended the week, we weren't able to talk about the patterns, but this is how we're going to start the next week, talking about what patterns are we seeing with all these problems, so that we can build some rules. Because the goal is to change these subtraction problems to addition. And remember, I said addition seems to be a concept that students grasp onto a little bit quicker, a little easier. Well, if we can change the subtraction to something that they understand a little better, it makes it that much easier for them. So in this problem, again, I'm starting off with 4, and notice there's no negative sign, so that's 4 positives. So 1, 2, 3, 4. Okay, and again, remember, I got to keep this value of 4. Okay, I can't change that value. So it's asking me to take away 2 negatives. Well, again, I don't have 2 negatives. So I'm going to go to the bank. I'm going to borrow 2 negatives. But what do I have to do? I have to pay it back. Now, this time, notice I borrowed 2 negatives. So to pay it back, I have to pay it back with 2 positives. And again, notice the value of this right here is 0. It's nothing. And notice I've been able to maintain my value inside my circle. This is still 4. It looks a little different, but it's still a value of 4. So I haven't changed anything. So now I can take away my 2 negatives. There they go, leaving me with, again, I can literally count 1, 2, 3, 4, 5, 6. I get an answer of +6. And again, this is where students start to see, hey, well, this is the same as 4 plus 2. And that's what we're going to start off next week talking about, well, how does that work? Why is this the same as 4 plus 2? Okay, and it has actually to do with this concept of what does that symbol really mean? Okay, so that was our focus this week. Next week, we're going to finish up with integers, and we are going to get to the messy world. We're going to get to those messy fractions and decimals. But this time, those messy fractions and decimals are going to get even a little bit more messy because they're going to involve negatives. Okay? All right, so I'm looking forward to another great week this week. Hope everybody has a great week, and hopefully we don't get too much snow. Have a good week, everybody. Bye.